Assalamu alaikum, dear students. Today we will discuss an important topic, that is the variation of acceleration due to gravity with altitude. What will happen to the acceleration due to gravity when we move above the surface of the earth? That's called its altitude. Can it increase? Can it decrease? We will try to see it. Before doing this, in previous class we have made an important relation. If you remember that g is equal to gm divided by r square, that acceleration due to gravity, we have calculated this relation. This g is equal to gm divided by r square. This we have calculated in previous classes. That means with the help of this relation, where you know that the g is universal gravitational constant, m is the mass of earth, r is the radius of the earth. In previous class we have discussed in detail, by substituting the value of x, this universal gravitational constant, mass of the earth, and radius of the earth, we can get the value of g. Value of g is approximately at 9.81 meter per second square at the surface of earth. Please remember, at the surface of the earth it is value is 9.81 meter per second square. Now today's class is how we will see the variation in acceleration due to gravity with altitude. What can we do? We can, that means effect of altitude, effect of altitude on acceleration due to gravity. We can take, suppose we can take here, suppose this is the earth. I can make a diagram here. Suppose this is the earth having a mass m, I'm supposing, and with center o. Suppose this is the center o, this is the earth having a mass m, and this r is the radius of the earth. Okay. Suppose this is we take point A on the surface of the earth, and we take another point B here, another point B. Okay, it is at the height of h above the surface of the earth. That means the height between A to B is called h, where we know that from this O to A it is called r. It is the radius of the earth. Okay, we take 2 points at A here, A, and at point B. Point B is at a height h above the surface of the earth. Okay, see, that means we have taken let a body of mass m. Let m is the mass and r is the radius. M is equal to mass of earth, mass of earth. R is equal to radius of earth, radius of earth, with center O, with center O. Since we have calculated the relation, suppose g is the acceleration due to gravity at a point, g is the acceleration due to gravity at a point A. But we know that acceleration due to gravity varies with radius. Since we know that mass of the earth does not change, universal gravity does not change, it is same everywhere. We have discussed in the previous classes, and r is the radius of the earth. That means radius means it is the basically it is the, actually, if you remember the previous class, it is the distance between the two bodies. But I have told you, when we take a body here above the surface of earth, suppose it is at a height of 20 kilometer, but the radius of earth is 6400 kilometer. This 20 kilometer is negligible. That means we are taking it radius. That actually this is not a radius, it is the distance between two bodies. It is the distance between two bodies. That means the distance between two bodies affect the value of g. The value of g at the, suppose the value of g at point A, the value of acceleration due to gravity at point A is g. Then we can see, by we have derived the relation. We know that g is equal to gm divided by r square, where this is equation first, where g is the universal gravitational constant, m is the mass of earth, r is the radius of the, r is the distance between two bodies. Here we can say it is the radius of the earth between this body A and between the distance between body A with the center of the earth. Every distance is considered from the center of the earth. Now, if we raise a body at a height h above the surface of the earth, its value of g will go on change. Whether it will increase or decrease, it will, because the distance between two bodies affects the value of g. That means the value of g does not remain same here. The value of g, which is at here, does not remain same at point B. That let g dash is the acceleration due to gravity, is the acceleration due to gravity at point B. Okay, at point B, at at a height h above the surface of earth. I already discussed above, at a height h above the surface of earth, above the surface of earth. That means this height, the height between a and b is h. That means we can again g dash is equal to by gm divided by r square. What is r? R is here the distance between two bodies. That is r plus h. It is the distance between two bodies is r plus h. R plus h ka whole square. This is equation second. Okay. Now we have got two equations. This equation and this equation. Now dividing equation first. We can go a mathematical dividing equation first by second. Dividing equation first by second. When we divide it, that means g divided by g dash. G divided by g dash is equal to gm divided by r square whole divided by gm r plus h ka whole square. Ultimately, we get, when we solve it, we get g divided by g dash is equal to gm divided by r square. This can be written as r plus h whole square divided by gm. Gm cancel, or I can write it if I transport g dash at here numerator, that means numerator will become denominator, denominator will become numerator. Ultimately we get g dash divided by g, but इसका भी उल्टा हो जाएगा r square divided by r plus h का whole square. Ultimately we get here g dash is equal to g r square divided by r plus h का whole square. Name this equation name this equation, suppose this equation third. That means equation third I can write here, I can write equation third here. G dash is equal to g r square divided by r plus h ka whole square. This is equation third. This is also important equation. Or I can write it here, I can write it equation 8, g dash is equal to g r square ऊपर, इसमें मैंने r square कॉमन निकालना है, r square नीचे, जब ये r नीचे निकालूंगा, बाहर निकालूंगा, ऊपर से r square ये हो गया, यहाँ 1 हो गया, 1 plus h by r whole raised by 2. I hope you have got it. ये r मैंने बाहर निकाला, जब बाहर निकाला मगर ऊपर स्क्वायर है, जब इसको बाहर कर इसको डिवाइड कर दिया, 1 plus h by r square and r square cancel. Ultimately we get g dash is equal to g 1 plus h by r raised power minus 2. Name this equation 4. We get this equation. We know that if h is very, since h is the height above the surface, it is very, if its value is very less than r, if h is very less than r, that means if h is very less than s, that means when we divide it by radius, it will become very small as compared to 1. It will become very small as compared to 1. But we are expanding it. We can expand it by using the binomial theorem. We can neglect the squares and higher powers of h by r. We can, you know the binomial theorem. 1 plus n raised by x is equal to 1 plus nx plus n into n minus 1 divided by 2 factorial x square plus higher powers of x. We can neglect the square and higher powers of h by r. When we expand it, binomial theorem, it becomes g dash g 1 plus n यहाँ minus 2 है, ये हो गया minus 2h divided by r. Higher powers में neglect करूँगा, ये मुझे relation. Ultimately I get this relation. This is equation 5. Okay. From this equation, g dash is the acceleration due to gravity above of the surface of the earth. It is clear from this equation, it is clear the value of acceleration due to gravity decreases with height. Why it is decreases? Because it will take some value. It is 1 minus some value, that means it become 1 less than 1. When it become less than 1, that means acceleration due to gravity goes on decreasing. It goes on decreasing. That means here we have to if it is only 1 here, then g dash is equal to g, then it is equal to the acceleration due to, but we have to subtract it some quantity. When we go higher and higher, we have to go on subtracting. When on subtracting, that means, but the value of h here becomes large when we go above the surface of earth. When we go above the surface of earth, this becomes more and more value. That means value of acceleration due to gravity goes on decreasing. From the equation that I hope you have got it, from equation 5, it is clear that the acceleration due to gravity decreases with height. That means it is decreases with height. That is why it is the reason. अगर आपको कोई पूछेगा, अगर आप if you are sitting in the plane and somebody is sitting at the mountains, acceleration due to gravity आपका ज़्यादा हो जाएगा क्या उस, because we know that acceleration due to gravity decreases with altitude. Therefore acceleration due to gravity is lesser at mountains than on plains. अगर हम कोई आपको बताएगा, अगर अब ये है एक्सेलरेशन ड्यू टू ग्रेविटी अबव द सरफेस ऑफ अर्थ, हम इतना ऊपर जाएंगे, वी कैन गो टू द इक्वल टू द रेडियस ऑफ अर्थ, दैट मीन्स 6400 किलोमीटर. When we move above the surface of earth 6400 kilometer, that means equal to the radius of the earth. What will happen to the acceleration due to gravity? What will happen to the acceleration due to gravity when we, that means at a height, that means when we go above the surface of earth, its value will go on decreasing. At mountains, its value is lesser as compared to plains. At a height above the surface of equal to रेडियस ऑफ अर्थ. अगर हम ऊपर जाएंगे, रेडियस ऑफ अर्थ, ज़मीन की सतह से ऊपर जाएंगे, कितना ऊपर जाएंगे, जितना इक्वल होगा रेडियस ऑफ अर्थ, आर के बराबर जाएंगे. दैट मीन्स तब कितना, दैट मीन्स दैट केस एच इज इक्वल टू आर, जो हाइट हो गई वो आर के बराबर. वी हैव मेक दिस रिलेशन हियर, रिलेशन थर्ड हियर. व्हेन वी सबस्टिट्यूट द वैल्यू ऑफ एच इज इक्वल टू आर इन इक्वेशन थर्ड, वी कैन गेट g dash is equal to r square in equation third. When we substitute r square r plus h के बजाय r का whole square. I hope you have got it. g dash is equal to r square, ये हो गया 2r का whole square, 2r का whole square हो गया 4r square, r square and r square cancel. That means here ये g already साथ है, g, that means g dash is equal to g divided by 4. That means what does this indicate? That means when we move above the surface of earth at a height equal to the radius of earth, the value of acceleration due to gravity is 1/4 times that means value of g. That means जितना value of g हो इसको डिवाइड बाई 4 करेंगे, जितना इसका वैल्यू आ जाएगा इतना वैल्यू ऑफ g above the surface of earth, above the surface of earth equal to the radius of earth. That means clearly हमने ये दिखाया, when we move above the surface of earth, the value of acceleration due to gravity goes on decreasing. At a height above the surface of earth equal to the radius of earth, the value of g is equal to g by 4, g dash is equal to g by 4. So that means 9.81 divided by 4, जितना इसका वैल्यू आ जाएगा इतना वैल्यू ऑफ जी हो जाएगी. दैट मीन्स वैल्यू ऑफ एक्सेलरेशन ड्यू टू ग्रेविटी decreases when we move above the surface of the earth. Thank you very much.